have a look at how you can run validators, Ethereum validators, using Lido's community staking module and distributed validator technology. In this case, we'll be using Obol specifically. All this information, step by step, is here in the Lido documentation. And let's go ahead and start with some preparation steps you need to do beforehand. One thing to have into consideration is that you can do clusters in a ball with as few as 4 operators, but we would recommend at least 7 because that's the minimum configuration to tolerate 2 malicious nodes. In this video, I'll be using 4. All of them, it's me, essentially. And then when you create a cluster, first, you need to appoint a leader. This leader is going to be the one helping coordinate everything in the Obol Launchpad that we'll have a look at in a bit, in Lido, etc., etc. Then this leader would have to collect the addresses for all the cluster members. With that information, he creates a safe multi-sig wallet. If you're doing a cluster of 7, we would recommend a threshold of 4 or 5. This safe will be used as sort of the manager of the operator in Lido to be able to make changes on the operator, to upload more validators or whatever. And then you would do a splitter contract. This splitter contract would take the rewards and automatically send them to the addresses of the cluster members based on whatever allocation you guys decide, whether it's split evenly or one person has more or less, that's up to the cluster. Finally, each operator would generate an Ethereum node record with Obol specifically, and that's something you need to back up securely in case something happens with your setup, in case you want to move setups. This is needed because you cannot generate these again. Then you need to decide how many validator keys to run based on the bond amounts. There's a calculator here in the useful tools. And every operator needs to be running a full Ethereum node that's preferably synced before we start all of this, and MEB boost configured with Lido beta release. Cool, so let's get started. Here I have in my terminal, I'm connected to a server that I'll be using for this. And here we have step-by-step how we would do it. First thing is cloning the Chiron repository here. This repository contains Chiron. Chiron is the client of Obol. It also has an execution client, a consensus client, a validator client, and MEB boost. So with this, we can set up everything, which is very convenient to test these things. Then we would move to the folder, create this folder. We can see here all the folders and files that were downloaded are inside here. And now we would have to copy this environment sample from Hudi and name it just .env. Cool. If we check again, we can see that here it is. We also want to make sure that the user has Docker privileges. Here, good. Now the next step is to generate the Ethereum node records. We'll come here, run this command. We'll take a second. I've run this before. If it's the first time you run it, it will need to pull some images first. And here we have it. Here's the ENR. It starts with ENR and 2 points and usually ends at a number. So we can copy this. Then you would set up a multi-sig wallet and a splitter contract, which I won't really show in this video. Now we can get into it. The first thing is to go here to the Obol Launchpad. Here we say, okay, let's create a cluster with a group. We get started. I would really, really encourage everyone to read all this information. There's important disclaimers and considerations. We get started. There's some explanations about proof of stake, about understanding distributed validators, about the risks of running these things in a group. But let's confirm everything. And it asks me to sign. Okay. Now let's put a name to the cluster. Let's say CSM plus Obol. The cluster size is 4. And here are the node operators. For the node operators, the first address is going to be this address that I'm using. The second is this one, and this one. For the validators, let's just say that I'll run 2 because we'll be running these with CSM. You don't need to pay attention to this. This is the amount that would be required to deposit to the validator itself. But remember that in Lido we put the collateral, and then Lido with deposits would fill this in. And here I will have my ENR. Good. In the withdrawal configuration, we have multiple options. In this case, we'll do Lido CSM. So it's going to configure both the withdrawal address and the fee recipient as those of Lidos. And you can check this on the on Etherscan. Here in testnet, they are not tagged. In mainnet, it would say Lido execution layer rewards world, and all of those addresses are also here in the documentation. Now we come here to create the cluster configuration. We confirm that all the information is good, that looks good. And now I have to sign a message with my wallet. None of this requires gas, so that's not a problem. Cool. So the cluster has been created. Now you would share this group link with all the other members of the cluster, and it would take them through the same setup. Just confirm that everything is okay and associate their ENR with their address. Okay, and after all operators have accepted the configuration and confirmed everything, then we can go to the distributed key generation part. Here we get this command. We would input it here in our machine. This will pull this image right now. And I had my other instances running this already. So it connected to all of them, it started the DKG ceremony, and it already completed it. So with this, we can come here and find our dashboard just right here. This is in the Obol Launchpad, right? Good. So we are done with this. Again, back up this folder. Let's quickly check this folder. Here we have the parent key, the cluster log, some deposit data, and the validator keys. It's very important that you back up this folder in case something happens with your setup or you need to move it elsewhere, because the information in this folder cannot be regenerated later. Now, let's configure MEB Boost. For this, first we need to open the environment file that we made before. Here you can see multiple things. The first thing that we're going to do is remove the comment from here and have this be true. After that, we're going to use some of the Lido embedded relays. We can open this here. There's a notion table with some of them. We go to Hoodie, and let's just put 1. For instance, let's put the first one here. We go here, and we need to find out this part that says MEB boost relays. This is in the MEB boost part here. Okay, MEB boost configuration, and here are the relays. What we can do here is I'll just add a new line because that one has put already. So let's just put relays equal, and we copy it. Now we have it. By default, it does have some of the require relays anyways, just for the sake of the example. Now we do is save, exit, we're good to go. Now we can start the node. Run Docker Compose up. This will pull all the images, which are Lodestar as the validator client, Nether minus execution, MEV boost, Prometheus and Grafana for monitoring, and Lighthouse as consensus. You can, of course, in the environment file also deactivate those if you're running the clients already elsewhere in your machine, and you connect Caron only to your existing client pairs. And now let's go to the CSM widget. Here we will click Create Node Operator, and up here we will put the deposit data. We'll copy that in just a second. But before that, we will come here to specify custom address. And here's a few things that we need to take into account. For clusters like this one in Obol, instead of default, we would choose the extended mode. So by default, the reward address is like the root admin of the operator. And so the reward is the one that receives the money, but also is the only one that can change both the manager address and itself later on. But because splitter contracts cannot sign transactions, we need to put it on the extended mode. In the extended mode, the reward address is still the one that receives the rewards, but the manager address is the one that can change both the reward address to any other address in the future and itself. So here we click extended. Then I have deployed a simple multi-sig here in Hudi. We can put it here. Just remove this. And as the reward address, just for the sake of this video, I didn't make a split. I'll just put my wallet. Now we can copy deposit data. I have already copied here. We will go here, come here, and confirm. Now we can go ahead and create the node operator. We confirm that everything is right. We'll continue. And we sign the transaction. While we wait, let me show you just where the deposit data is here. You would come here to the current folder. Here you can see that you have multiple deposit data. In this case, you would use this one. And you can do something like cat current deposit data.json, have this and copy it over to a notebook like I just did. And that's it. Now the keys are with Lido. As soon as there's deposits, they will be deposited to and processed in the beacon chain. Now the only thing is that you need is to keep your nodes synced and have some good communication with your fellow node operators in the cluster.